Given the root path in a file system, find all files with the same content. Hi everyone, we're here today for another Exponent mock interview with Idan. For those of you who aren't already familiar with Exponent, Exponent helps you get your dream tech career with our online courses, expert coaching, peer-to-peer mock interviewing platform, and interview question database. Check it out at tryexponent.com. Okay, thanks for being here with us today, Idan. Would you quickly introduce yourself for our viewers?
Sure. Currently a senior engineer in Canva. Previously, I worked in AWS as well, mostly on the back end.
Great. Okay, so I'm really excited to see your take on our question today. So the question today is, given the root path in a file system, find all files with the same content.
Okay, cool. So first thing to do is just to clarify the question a little bit. So we're given some path that we need to explore all the files under that path, and we need to find the duplicate files, and I guess return them or print.
Yeah, if you could group together the duplicate files, that would be great.
Okay. So we can, the files that have more than one file that has the same content, then they should be grouped together. If there can be two or more files with the same content, and I can group them together and then return them.
Mm-hmm. Yeah.
Right. And so, because this question is about interacting with the file system, that might change based on the operating system or stuff like that, depending in some languages. I think in Python there's library functions, but I assume I have some APIs to interact with the file system?
Yeah, you can assume that you have a basic file API that handles most open read and write operations.
Yeah. So so I can write in these function signatures down, these APIs that I can use.
Yeah.
So I would need list directory function to read all the files under some directory. Is file to understand if a path is a file or a directory, is there maybe to understand if a path points to a directory, and I guess read file, something like that. I think that's very similar to the Python library functions that I have, at least the first. Cool. So I have, so going into solving the question, I think, so usually when we need to compare many objects, it's smart to use a map or a set.
Okay.
Instead of comparing all the pairs, which is really slow. So it's the basic idea is I read so I need to walk the path recursively to get all the files, file paths. That's one portion. And then secondly, I need to read the files and then add the contents to the map, and then I can check for equivalence in that map. But I realized there's a big problem with that, because it doesn't make sense to store all the contents of all the files in my map. I don't think I'll have enough memory to do that. So I realized I need some fingerprint or some I can use a hash function on the file content, and then I can compare the hash and find equivalence that way.
Okay.
right? So if I can assume I have another API similar to read file, but like, yeah, calculate hash of a file, right? Then I can do it like that. There's just a small question of usually there can be a very small chance of a collision with, so this means files that actually have different content, but they have the same hash. Like we can use MD5, for example, but the question is, can I, because I think it's a very small chance that it will happen, can I assume, like, ignore that edge case?
Yeah, for now, I think you can assume that it doesn't happen often enough for it to be concerned.
Yeah, cool. Thanks. So I think I have a pretty good idea of how to solve it. Can I get into coding? So first, yeah, so as I said, we can do it with two parts. So first, let's walk sort of a directory. So yeah, it will start with, based on some root path, and I need to gather all the file paths. So instead of doing it recursively, I can just use like a stack or a queue. So it can start with have a stack just with the root. I have all the paths I want to gather, and then just need to do a while stack. So current directory, and then do current files. I need to use the list function. And yeah, if I assume I get the full path of the files here from the list directory, then I can just do so for file, then it's like if is file, then I add it to the results. And
right, so just to clarify, this lister function, it's not recursive.
No, so correct. So I think that would be too easy if it will just that's like the solution that I'm implementing. So I assume this is just a one, like, list the immediate content of the directory, so it can return files or directories, and then I need to recursively walk it. So, and then I can do is dir on it, because maybe it's not a file and not a directory, like symlink or whatever. So, and here I'll just append it to the stack. And yeah, I think in this way I just gather all the files.
Yeah.
And then so now I can do the find duplicates, assuming I have a list of paths, right? So what I can do is, so I need a map, like a dictionary between from the hash to the paths that have this hash. And then what I can do is for path, I'll calculate the hash function. So And then I want to edit. I want the value of the dictionary to be a list of paths. But if it doesn't have if I didn't initialize it already, then I need an empty list plus the new value. So what I can do is I can get with a default. So I get it, file hash, or an empty list, and I'll append to it the new path. Like this. And then basically the grouping is just, so the values are the lists, like for each different hash, there's a list of the equivalent files. So I can just do values, return the values. Yeah, and then my sort of main function will be, like pretty much the solution is to do find duplicates on my work result. Of the path that I want.
Okay.
Right.
I'd love to see you test this on a few test cases then.
Okay, sure, I can do it. So yeah, I think usually, I would, like, if this would be library functions, then I would mock them. But I think for the purpose of this interview, I can just, this would be very similar. I'll just return the mock value here. Mm-hmm. So because I need those values, mm-hmm, of the functions return. So let's say this here returns, like I can do like that. If path is equal like /home, then return /home/1.txt, and another directory, let's say, directory. Then if path is this, then I return to a second file, right? And then, so I'm doing is file. So I need to return on 1.txt and 2. I assume it returns the full path, so I need to do it like this. The copy. So I can just do return path in like this, and then is there, mm-hmm, will return on the directories, is path in home or home there. Mm-hmm. And then this I don't think I need. And this I'll do later. Let me just to see. So okay, so then I walk. So yeah, like firstly I can test walk directory to see if that works. Mm-hmm. So if I print Yeah, so I have this should return if it's /home. Yeah, let me try to run it then. Oh, I haven't run it syntax. Line
I
one.
think you
Yeah,
probably
it's just our notes. Okay, let me try again. Okay, /home/1.txt, but I didn't get it, the recursive. I didn't get about /home/. I think it's because, I just have a missing slash in my input here. Oh, what's that? So just tagging. So I have line 24 non-type. So yeah, that's because for /home/dir. No, why did I try to do it on non-type? It must be because I try to list dir on something that is not one of these.
Yeah.
The question is why? Because I should have done it only on /home, started in /home, and then I've done it on, oops, what have I done here? I was supposed to do stack.append file.
Yeah.
Right.
Sorry, why? Okay, gotcha. So you're okay. I see. Yeah.
Just mistyping. I think. Okay, this one looks good.
Great.
And then cool. So then, if instead I try to test my full code, which is here, I just need to do the calculate hash of a path. So what I can try to do is, let's say they have the same hash, right? These two files, I have these two files, right? If they have the same hash, I'm expecting them to be in the same group, right? So just another parentheses. So I get them in the same group.
Perfect.
But yeah, and I can do a list instead of these dict values. And then if they are different, let's say I return path, right? Then I expect them to be on separate groups, right? Like so.
Yeah. Great. Okay. Awesome. So I think this is a good place to pause and talk about some like follow-up questions and analyze this interview a little bit. I'd love to hear from you. What was the runtime and space complexity of this solution?
Right. So the runtime complexity is, so I have to assume to calculate the hash of so if I assume to calculate the hash and I need to read the whole file, to calculate the hash on it. So basically I'm just working on all the files from the root and calculate the hash, and then I'm doing just O1 operations here. But reading those files to calculate the hash is the major component of my time complexity. So basically, it's linear in the size of all the files like together. So yeah, which might be long, but the space complexity is based on the number of files. Is like linear on the number of files, because I just use a constant, like a few bytes of hash per file and not the whole file.
Okay, perfect. Great. So I'd love to hear your analysis of how this interview went. Like, what do you think went well, and what do you think you would want to improve in the future?
Yeah, so I think it went like, yeah, I clarified the question. Like, I think we had the same expectation of the question, which went well. And I think, yeah, I found a pretty good solution and implemented it without, I think, too many major issues. Mm-hmm. Maybe the part that didn't go well is, it's just this basic small mistakes in the code, which could have been improved maybe with more practice, or just like if I taking it slower before running the code and just looking over my code to see those problems before I get them when I run.
Mm-hmm. Yeah, that makes a lot of sense to me. And, even though you did have that bug, like you were able to catch it yourself, which without me having to point it out. So that is one thing that I really liked about this interview. I liked that when you were testing, you tested each of your helper functions in isolation. So it's easier to catch your mistakes that way, right? Because if you had straight up find duplicates without testing walk directory first, then there's much more code for you to search through to find the bug. And in addition to that, I agree. I really like that you checked all of your assumptions with me before proceeding with coding. So you checked like what functions in FL API that you had available to you and whether or not you had to pay attention to the hash collisions. And I also thought that this was a really good demonstration of how you might mock the return values of functions when you're testing. So that was really awesome as well. And as you said, you came to a really smart and efficient solution and implemented it on your own without any major issues. And then I think one last thing that might be helpful to do in these types of interviews is to maybe briefly summarize what your approach is going to be before diving into coding. So you had already mentioned that you would check for duplicate files by hashing them and then checking the hashes against each other, but it wasn't clear how you would actually walk the file tree because you ended up doing kind of like a depth first search of the file tree, right? So I think that was like an important part of the algorithm as well. How does that all sound to you?
Yeah, that makes a lot of sense.
Okay, so you did a fantastic job. Thank you for joining us today. And thanks everybody for watching. Good luck on your upcoming interviews. Bye, everyone.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video is valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.